7 is kind of a different problem, although it doesn't look that much different from the start of it. But let's just treat it like any other one. So I want to let u equal what's in the parentheses, so 2x squared minus 8. And then I want to take the derivative. So this is going to be du is equal to 4x dx. And I'm going to actually leave the x with the dx, because if you look at the original problem, I do have the u that I have here, but I have this extra x that I need to worry about. So we need to somehow take care of that x. So the fact that I have a x here on the bottom, that's actually a really good thing. So I'm just going to divide both sides by 4. So this is going to be, let's put a note here. I want to leave the x. So 1/4 du is equal to x dx. So the x dx is going to get replaced with 1/4 du. And that's the x and the dx together, not for both of them, but both of them together will become 1/4 du. So if I substitute, this is going to be, and if you want to rewrite it, you could. So so some people it bothers that the x and the dx are not right together. So if you want to show them together, then you can. But if you can just see the original, then that's okay as well. So when I replace this, this is going to be 5u to the 3 times 1/4 du. Again, we need to have all u's and du in order to integrate. That's why getting rid of that x was such a big deal, because I can't just have an x in here when I'm integrating. It needs to be all u's and a du. So that if I actually integrate this, well, I have the 5/4 there times u to the 4 over 4 plus c. And then if I substitute back, it's going to be 5 over 16, 2x squared minus 8 raised to the 4th plus c. So this problem, again, had that extra x in there. So that's something that we need to look out for.